Welcome, my dear students in Prep 3. Today we will study probability. Our first lesson in probability is operations on events, and this is the first part. We studied before the random experiment, and we said that this is an experiment in which we can specify all the possible outcomes before performing, but we can't determine which one of them will occur certain. Okay? So this is the random experiment. This is an experiment. I know the result of this experiment, but we know all the possible results, but we can't determine which one will occur. Also, we studied the sample space, and we said that the sample space is the set of all possible outcomes of any random experiment. What about the event? The event is a subset of the sample space. It means it's just a part of the sample space. Also, we studied how to calculate the probability, and we said that the probability is the occurring of any event. For example, if we have an event A, then the probability that A is occur is the number of elements of the event A over the number of elements of the sample space. It means that P of A, it means probability of event A equals N of A over N of S, where N of A is the number of elements of A and N of S is the number of elements of the sample space. Let's study some operations on events. At first, we will study the intersection of two events. As we said before, the probability of the intersection of two events, for example, the events are A and B, is the probability of the occurring of A and B together in the same time. So, the probability of A intersect B equals the number of elements of A intersect B over the number of elements of S, which is the sample space. We have the sample space S, and we have two events A and B. Then the A intersect B is this zone. This is A intersect B. Then the probability of A intersect B is the number of elements in this zone divided by the total number of elements or the number of elements of S. We have also the mutually exclusive events. This type of events, there is no intersection between the two events. For example, this is A and this is B. There is no intersection between event A and event B. Okay, so here A and B are two mutually exclusive events. Then A and B are disjoint. It means that A intersect B is 5, and then the probability of A intersect B should be 0. The two events here, for example, can't happen together in the same time. Let's take an exercise. This exercise, an experiment of drawing a card randomly from 9 identical cards numbered from 1 to 9. So we have 9 identical cards from 1 to 9, and we will pick one randomly. If A is the event that the drawn card contains an even number, B is the event that the drawn card contains a number less than 7. Find the probability of occurring of the two events together. Here we have A, the event that this card carries an even number. What are the even numbers from 1 to 9? We have 2, 4, 6, and 8. So A is 2, 4, 6, and 8. What about B? B is a number less than 7. So we have 1, 2, 3, 4, 5, 6. Okay, so we have two events, A and B. Now I want a number which is even number and in the same time less than 7. So we have 2, 4, and 6. So the number of elements of A intersect B equals 3 numbers, 2, 4, and 6. Then the probability of A intersect B will be 3 over 9, because here we have 9 chords, so n of s equals 9. Okay, so A intersect B, it means that the two events happens in the same time. It means that the number is even and at the same time less than 7. So we have 2, 4, and 6. The number of elements of A intersect B will be 3 elements, and the total is 9, so 3 over 9. The union of two events, it means A union B, is the event occurring A or B. Okay, the event of occurring A or B or both. This is A union B. Okay, so the probability of A union B equals the probability of the number of elements of A union B over the number of elements of S. Here, for example, we have A and B. A union B, it means this region and this, and also this region. So this is A union B. Okay. Also, for any two events A and B, if I want to calculate the probability of A union B, this probability will be the probability of A plus the probability of event B minus the probability of the intersection. So, if A and B are two mutually exclusive events, then probability of A intersect B will be 0. So, then the probability of A union B will be only probability of A plus the probability of B. Here we have an exercise. If A and B are two events, probability of A equals 0.8 and the probability of B equals 0.7. The probability of A intersect B equals 0.6. Find the probability of occurring the events A or B. It means A union B. So we said before that A union B, the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. So it will be 0.8 plus 0.7 minus 0.6. So this probability will be 0.9. Okay, so this is the probability of A union B. That's all about part 1 in operations on events. Next session we will talk about part 2. It will be the second part of operations on events. Thank you very much for watching. See you next session and goodbye.